All right, as promised before, we're going to be comparing two float values against each other to see if they're actually equal. Now, we've seen in the previous examples that we use the equal operator to compare two float numbers, but I've warned you that is not the best way to do things, especially if you're taking actual measurements, right? Let's say you have two cities and you're taking measurements between the two cities in kilometers, but you could be off by a few hundred meters or a few tens of meters. And some of the discrepancies in there might be tolerable, hence the keyword tolerance. Okay, since you're pretty much estimating the distance between them, right? So tolerance is a major factor when you're doing a lot of measurements in terms of distance, time, anything that is finite. So being able to set the tolerance or the acceptable margin of error is an important part of programming as well. So you can't have technically two float values exactly equal to each other in the real world. So you can get close, but how close? You have to define what that tolerance is, what that difference is. So we're going to be doing that right now. And I'm going to do several examples on how to set this up. Oh, by the way, I just remembered, someone had asked me, is there a way to get rid of system pause and use something else since they were using a Unix-based system? And the answer is yes. There are several techniques on how to do this. You can create your own function for pausing the screen. Or you could, I'm going to cheat here and show you a baseline library that is from C, and I'm going to use its function. I'm going to do this. Include conio.h. Now, this is a header file, okay, that will allow me to use a function called getch. It's a function. And now let's see how this behaves. So let me just compile and run. And you can see it's blinking here, right? So if I enter, it will hold the screen and blink for me until I hit enter. Okay, so what it's doing, it's getting a character from the keyboard. Okay, so let's leave that in there, right? Instead of system pause for this example. And let's focus on our main objective. And we're going to do it one way, and then I'll show you another way to compare two float numbers. So let's say I have double num1, num2, right? So we're going to ask the user now to enter values for num1, num2, and then we will compare them to make sure, to give a message that they're kind of equal within a certain range. Okay? So the way to do this, again, so we're going to ask the user to enter num1, okay, and then cin num1. We're going to do another one, cout, enter num2, and then we're going to do cin num2. Okay, so we've got the two numbers now in place. Now we need to compare them. So we need some sort of an if statement, since that is pretty much the main objective where we need to be, conditional programming, but we're applying it to a particular case where we're comparing two float numbers for equality. So I am just going to leave a space here because that is where the Boolean expressions, right, the logical expressions are going to be written out to evaluate how close is num1 from num2. And if they are close, then I would like to get a message that says num1 and num2 are close enough within tolerance. Which, in other words, technically they're equal. Okay? You have to set the idea what equality is. Well, let's do an example. Let's say I want to set it up this way. So the difference between num1 and num2 is going to be important. Now remember, num1 could be larger than num2, num2 could be larger than num1, so you're going to have to take into account these two possibilities. And you're going to have to stay within a certain range. So if you're dealing with ranges, and it's the inner range between a lower value up to an upper value, then you're going to be using an AND function, right? We've seen the AND function before. So how do you do that? So I need an expression ANDed with another one. And what's in the first expression? Well, you're going to compare num1 minus num2 as long as it's less or equal to, and here set your tolerance, positive 0.01. Well, great. So that means now that is true if num1 is greater than num2. Now, what about num2 being greater than num1? So that possibility is going to be here. Num1 minus num2 is greater or equal to minus 0.01. So now you've got a range where 0 is at the center, okay? So you're either at plus 0.01 or minus 0.01, right? So now you've got a tolerance. So you're within a certain tolerance where 0 is technically the center. Okay, well, let's see how this behaves. So let me compile and run. And notice my tolerance is 0.01, right? So right there. So let's go ahead and do a 0.11, and we're going to compare it to 1.101. And sure enough, we're within that tolerance. Okay? Let's do another example. Let's run it. And this time I'm going to do a 1.1 against a 1.2. And notice now I get no cout statement num1 and num2 are within the tolerance. But I do get my blinking cursor, right? So that means the if statement produced a false somewhere. And we're not within that range. Okay? So I'm going to hit enter. So let's go ahead and do it again. Run. And I'm going to put 1.01 compared to 1.02. Let's see what happens. And again. Right? So we're not within that range. So now let's do it again. Run again. So you get to see how mathematically this works. So 1.01 and now 1.01, let's say 4. That's close enough based on what we want to do. And sure enough, we're within the tolerance. So I hope this gives you an idea on how to do it this way. Now, is there another way? Absolutely. So if this gets confusing and you're seeing that you're looking at the difference between num1 and num2, why not use an absolute value of the difference of num1 and num2 against 0.01 all at once? Okay? So if I go over here and I look at the, this is the standard library, by the way. Here's the function ABS. Okay? Either you're using C++ 98 or C11, pretty much the same. You give it a double, it will return a double, right, as the absolute value. So that means if you gave it a positive value, it returns a positive value. If you gave it a negative value as an argument, it will return a positive value, right? So what we're going to do now is I am going to modify all of this into a single statement, right? So we've seen this works just fine. It sets the range for me, right? So now let's do this way. ABS of the difference, num1 minus num2, as long as it's less or equal to 0.01. Now let's see if we get the same effect. So let's compile and run. Let me see here. I'm missing something. ABS is a function, so it needs to come from somewhere. Now remember, when I showed you this is good that we got this error. It says, I don't know who ABS is. It was never defined in this program. But we do know that it exists, but to bring it, you need to include CMath, the library CMath. That's where the ABS function was defined. Just like we did get she here, this will not work if you didn't have conio.h. You could not do cout if you didn't have iostream. So again, here we're going to include CMath, and then we shouldn't have a problem. So let me compile and run now. And there you have it. So now let's do the same example. 1.01 against 1.013, and we're within tolerance. Okay, let's go ahead and run it again where we're not within tolerance. So I'm going to do 1.1 against 1.2. And as you can see, I get no message. Right? So no news means nothing happened. They're not even equal. Right? Because I have an if statement without an else here. So I did not take into contingency what happens if they're not equal. Could I get a message? Okay? And that's where we're going to go back and review if statements again with the else statement to make your program a little more user-friendly. Okay? So remember here, this here is an if statement without an else. And we could see that it has a drawback for this particular scenario. What if the two numbers are not equal? A lot of users are going to enter these numbers and they're not going to understand the fact they're not getting a message that they're not actually equal. Okay? So that is one scenario where an else may be recommended. Okay? But the program works. It doesn't really need the else to evaluate. Okay? Fantastic. So I'll see you in the next video. We're going to get back to if statements. We're going to be doing more nested if statements, either on the true block or on the false block, which is under the else. And that will give us a chance to reuse if statements with else.